Hello students and welcome to IP Study Lecture videos. In this video, we are going to cover the chapter number 2 of grade 7 part 1 and the name of the chapter is Arithmetic Expressions. First of all, let us see what are the different topics we are going to cover under this chapter. So we'll see what is an arithmetic expression and what is the difference between simple and complex arithmetic expression. Then we'll understand what is term in an expression and then properties of adding term and how to solve bracket in an expression. So let's start with the first topic of our chapter, which is arithmetic expression. Students, we know that we apply operation between two or more numbers, and there are four basic operations that we apply like addition, subtraction, multiplication and division. So when we write numbers along with operation, the expression is called arithmetic expression. You will also study in the later part of this book that what is an algebraic expression, where we use letters as well as numbers with operations where we call them as algebraic expression. But as of now, we are using only numbers, and these expressions, which is numbers along with operations, are called arithmetic expressions like 18 plus 5 or 30 minus 10 or 7 times 4, 50 divided by 2 multiplied by 3. They can be multiple operation also. Now, there is a case where we have to understand there are two type of we can say arithmetic expression. One is simple and one is complex. In simple, we generally use only one operation like 2 multiplied by 8. There will not be any other operation than this, like multiplication is only one operation that is being used over here. 18 plus 5, this is also an we can say a simple arithmetic expression. Here, the numbers that we use are called operands, and the operation that we apply like multiplication, addition, subtraction are called operation sign or operation that we use. Okay. So, next is value of an arithmetic expression. So, when we solve an arithmetic expression based on what operation does it have and what numbers it is using, we get a value, and that value is called value of an arithmetic expression. Like if you have 18 plus 5 as an arithmetic expression, then we can write its value as 23 because 18 plus 5 will be 23. Next is equivalent arithmetic expression. There can be various arithmetic expression which can result into same value of that arithmetic expressions. Like if we have 15 plus 5, it is also 20. 25 minus 5, it is also 20. So expression, either it is complex or simple, which gives same result on its evolution or on solving them, then those arithmetic expressions are called equivalent arithmetic expressions. Now, comparing arithmetic expressions. So, we know that we can compare arithmetic expression by solving them, but sometimes we can use a shortcut method where we have to just generalize or we have to analyze what is given to us to compare, and we can use shortcuts to compare them. Like if we want to compare 504 added with 102 and the second part is 505 added with 100, and now we want to compare them, that which expression is greater or smaller or are they equal. So in that case, we just break them into similar components, like 504 can be broken as 500 plus 4 and 102 can be broken as 100 plus 2. Similarly, 505 can be broken as 500 plus 5 and 100 is 100 only. Now, on going forward, we can see that this will be written as 500 plus 100 plus 6 because 4 plus 2 is 6, and here it will be 500 plus 100 plus 5. Now, we can see that out of the three component, we have two same component 500 and 100. So 6 and 5 that we need to compare. So we know that 6 is greater. It means this expression will be greater than this expression. So here, without solving or getting the value of the expression, we can just compare using these tricks. Okay. Now moving to the second type of arithmetic expressions, which is called complex arithmetic expression. So in complex arithmetic expression, the numbers will be grouped with operation where we have more than one, like 2 operations or 3 operations together. Now, solving a simple arithmetic expression is quite easier than complex. So for complex, we need to understand some rules and how steps to understand how we'll get the answer or value of that arithmetic expression. Now, an arithmetic expression that contain more than one operation such as addition, subtraction, multiplication or division is called complex arithmetic expression. Like 7 plus 5 multiplied by 3. We can see here we have 3 numbers and we have 2 operations which we have to perform. Here we have 3 operations, then 2 operations, then 2 operations. Now, need for bracket in complex arithmetic expressions. So we have to use the bracket carefully when we have arithmetic expression involving more than one operation, which is complex arithmetic expression. Why? Because same, like if we write 2 multiplied by 3 plus 6, we can get various answer, or we can get 2 answers for as of now. Like if we want to multiply first, we'll get 6 plus 6 as 12. But if we add first, then we'll get 3 plus 6 is 9 and 9 multiplied 2 is 18. So 2 times 9 will be equals to 18. So it is very important that in order to get the actual and the required result, we should use the bracket depending upon what we have been asked for. Like we have a situation where situation 1 says, Riya buys 7 candies for her brother and 5 candies for her sister. The cost of each candy is rupees 3. Now, in order to find out the total amount that will be used to buy those candies, we'll add the total number of candies that would be bought and then we'll multiply with the cost of one candy. So it will be written like this: 7 plus 5 multiplied by 3. So here we have to apply the bracket in addition part first, and then it will be solved first and then later on 3 will be multiplied to it. Now, in the second situation, Riya buys some candies costing rupees 7 and 5 chocolates. The cost of each chocolate is rupees 3. Now, in order to find out the total cost, we have to add the candies cost and the cost that 5 chocolate will have, like 5 times 3. So here we have to apply the bracket in 5 multiplied by 3 so that we can find out the value of cost of chocolate and we can add them with the value of or the cost of candies. So here it shows that applying or using the bracket is very important in order to solve complex arithmetic expression. Otherwise, we will not get the required value. Okay. Now, moving forward, let's solve one question given on exercise 2.1. Read the statement carefully, write the corresponding arithmetic expression and solve it. So, we'll see how to convert the statement given to us into an expression and how to solve it. So let's suppose B. A carton contains 6 packs of juice and each pack has 4 bottles. Each bottle costs 15 rupees. What is the total cost of all bottles in a carton? So a carton contains 6 packs of juice and each pack has 4 bottles. So we need to find out the total number of bottles first, because we have been given with the value or the cost of one bottle. So the total number of bottle will be 24. And in order to find, because 6 times 4 will be 24. So we'll write 6 multiplied by 4 first. That will give us total number of bottles that we'll have. And then we have to multiply it by 15. So our answer will be 24 multiplied by 15. Okay. So it will be, let's see what will be the result of 24 multiplied by 15. So it will be 20, then 120 it will be, and then 24. So it will give us 360 rupees. So the total cost will be 360 rupees. So this is how we have to convert the statements to expression and expression to its value. Okay. Now, terms in expression. This is the next topic that we have to cover. A term is an arithmetic expression where each part is separated by a plus sign. They are building blocks of an expression. Now, when we write expression, if there is a plus sign, then the numbers or the terms that we have, or we can say the expression that we have on the left part and right part of that plus sign, they are called term. Like 3 plus 4, then 3 is one term and 4 is one term. 4 multiplied by 3 plus 5, so plus is over here, so this will be the one term and this will be the second term. So 3 and 4 are the terms here, and 4 multiplied by 3 and 5 are the terms for this expression. Now, there are key properties of terms in expression. First is, subtraction can be rewritten as adding the inverse of a number. Like if we have 83 minus 14, we can write it as 83 plus minus of 14. Now, this is written in order to find out the term of an expression. So, terms of an expression for this expression will be 83 and minus 14. So, whenever we are given with expression and we have to identify the terms, we have to look for addition sign. If there is a subtraction sign, we have to rewrite them in such a way that they should contain an addition sign along with subtraction with the number that we'll have. Okay. Here we have example 3, which says, write the terms of the arithmetic expression given over here. So, the terms will be separated by plus sign. So, here we have 7 multiplied 2 plus 4 plus 8 minus 6. So, here as we can see, this will be the one single term because a bracket had been used with multiplication sign. So, it will be a single term. Now, this will be one term and this will be one term. So, terms will be 7 multiplied by 2 plus 4 and 8 and minus 6. You don't have to write 2 and 4 separately because it is present with multiplication symbol with 7. Okay. Now, moving to the next part, solving complex arithmetic operations by identifying terms. So, when we have to solve complex arithmetic expression, we have to identify terms in order to solve them easily. Now, here are steps which will help us to solve complex arithmetic expression. Solve any bracket first. If you have any bracket in the expression, you have to solve that first. Identify the terms. So, we have to identify the terms, which is often called as chunks. Evaluate each term individually first. Now, evaluate the reduced arithmetic expression. For example, here we have to solve this bracket first. So, 3 times 5 is 15 and then we have to write 5 minus 15, which will be equals to minus 10 because we can write it as 5 plus minus 15. So, it will be minus 10 because this 2 will be a single we can say expression which will be solved. Okay. Now, if I want to solve this one, we have 3 terms. One is minus 4 multiplied with 3 and we have 8 and minus 7. So, in order to solve them, we have to multiply first minus 4 times 3 because this is the single term that we need to have. So, minus 4 times 3 which will be minus 12 and then 8 plus minus 7 because minus 7 will be rewritten as plus and then minus 7. So, we can add any two, like 8 and minus 7 can be added first, or minus 12 and 8 can be added first, and then the result will be added with the remaining part. Okay. So, we'll get minus 11 as our final answer for this expression. Now, properties of adding terms. Once we identify the terms in an expression, we can add them in any order or group them differently. So, when we have terms, when we identify the terms of an expression, we can group them in any order. The value of the expression stays the same. Like if we solve, like if we have identified the terms and we solve the first term first or the last term first, it doesn't matter. We can solve them in any way. Just we need to follow the rules that each terms will be solved individually or bracket will also be solved first. Then we can apply the operation as we want. Okay. Now, first property is swapping terms, which is called commutative property of addition, that we already know that adding two numbers like 2 plus 4 or 4 plus 2 both gives the same answer. So, we can swap the numbers written on the right or left with each other. Okay. So, this works for this. This is also an expression. So, this is work for general expression also. Like if we want to do 6 minus 4, so we can write it 6 plus minus of 4. So, we can find using this also, or we can write it as minus 4 plus 6. So, both will give us the same answer because we have swapped the term. The value has not been changed for both. So, it says a plus b is equals to b plus a, which is commutative property of addition. Grouping terms, associative property of addition. So it is quite similar to numbers that we have been using generally. Like if we have 3 numbers to be added, we can add them in any order. Like we can add 2 and 3 first, and then we can add 6 to the result. Okay, or we can add 3 and 6 first, and then we can add the result with 2. So both says that we can add in any order. Okay. Now, last topic, which is rules for solving brackets. So complex arithmetic expression can contain various brackets. In this section, we will learn the rules for simplifying expression, especially those with brackets. This section focuses on important rule called the distributive property. It helps us understand how an operation outside a bracket like subtraction or multiplication is applied to every term inside the bracket. So basically it deals about bracket and operation outside it, okay, which is called distributive property. Okay, so distributing a negative sign. So if we have a negative sign outside the bracket, each term of that expression inside the bracket will be getting the negative part, or we can say negative sign, which will change the sign of the term. Like if we have a minus b plus c, so this is a bracket and negative sign is followed on its left, so it will be minus b and minus c. It will change the sign that is originally present with the terms of the expression in the bracket. Okay, like if you want to solve 200 minus 40 plus 3, so what we can do is, first is we can add 40 and 3 first, so it will be 43, and then we can subtract it from 200. Otherwise we can open the bracket and minus will be given to each of them, and then we can solve it one by one. Okay, like 200 plus minus 40 plus minus 3, which will give us as 157. Okay, similarly if we have a plus sign outside the bracket, so we don't have to change anything. We can just open the bracket easily. Okay, like if we have a plus b minus c, we can write it as a plus b minus c, and there will be no change in the sign present with the terms of the expression inside the bracket. Okay, next is tinkering the term or changing a term. So if we change the term of an expression, its value is changed symmetrically. Like if we increase a term by 1, the result of will be also increased by 1. Okay, like if we have 53 and we have to subtract 16 from it, so it will be 37. Now if we add 1 to 53 and then if we subtract 16 from it, we'll have 38. So as we have increased by 1, we can say 53 has increased by 1, so the answer is also increased by 1. So if we subtract something from our number, then the result will also be subtracted by the same amount. So decrease in a term by 5 result in the decrease of 5 in the final value. So we can just generalize it in a way that if we change something to the term present in the expression, then the result is also changed by its value. Like if we add something or if we subtract something, so its value will be changed by that value only. Either it will increase or decrease based on where we have added or subtracted, in the first number or in the second number. Okay. Next is distributive property of multiplication over addition. So if we have a multiplication sign outside the bracket, we have to multiply the outside term to each and every term inside the bracket. Like if we have b plus c inside the bracket and a is multiplied with the bracket, so we have to multiply a to b also and to c also, like this that is given here. For example, if you want to evaluate 2 multiplied with 43 plus 24, we have to multiply 2 to 43, then we have to keep the sign that we have like plus or minus, and then we have to multiply 2 with 24, which will be 134. Like here we have been adding first and then we are multiplying, and here we have been what we have doing is we have just multiplying the numbers first and then we are adding the result that is being obtained on multiplication. Okay, multiplication over a difference. Like addition, we can have a subtraction also in the bracket. So this is quite similar to what we have done, just we have to put subtraction sign over here. Okay, so next is tinkering the term, changing a number in a product. So if there is a product and if we change a number, so the product is also changed quite similarly, like changing one of the number. If one of the number in a product is increased or decreased, the final result changes predictably. We can calculate the effect that change directly. Like if we have to multiply 64 with 18, which result into 1152. Now 64 has been changed to 69. That is 5 has been added to it. Now we can write like this: 69 can be written as 64 plus 5, and then we can multiply using distributive property, and the added part that is required to be summed with the previous expression will get that result, and we can get the final answer as 1242. Simplifying multiplication with rounding and adjusting. So a common strategy for mental multiplication is to round one of the number to a near by multiple of 10 or 100. Like if you have to multiply with 49 and 36 together, we can write it as 50 minus 1 instead of 49, and then we can multiply 36 with 49 and then 36 with 1, and then we can subtract their values. So it helps us to easily identify the values first, and then we can add or subtract based on what situation is in given with us. So this is called this is used for mental strategy basically. Okay, like we have to solve it quickly, then we can use that. Like if you have to multiply 99 with 66, it can take time. So instead we can write it as 100 minus 1 multiplied with 66. That will give us the result. Okay, so using the distributive property that we have already understood in the previous part. Okay, now so this is all from this chapter. I hope you have understood this chapter very well, and we'll meet in the next class where we'll be understanding the next chapter. Till then, keep practicing, keep learning. See you soon.